Hello everyone, I am Santosh Nagendra Rao. Today I am going to present on directing the preventing financial institutional fraud. So coming to the introduction part, so fraud is one of the major problem in the financial institution in recent years due to more sophisticated methods and that has been taken advantage by the fraudsters and they are making loopholes and in the banking system. So it is affected to the both bank and the customers facing the losses due to the fraud. So to overcome this, we have implemented the fraud detection methods that can spot the fraudulent transaction and stop the losses. So in the financial sector, machine learning has recently played an important role um, to detect the fraud. We can just utilize the Cult-Edge algorithm to search the mountains of data. In search, the abnormalities and trends that might indicate the fraudulent behaviors. So the purpose of this paper is to examine whether anti-fraud machine learning techniques are useful or not. The first section is the introduction of various financial fraud and difficulties in identifying the frauds. Then paper goes the various machine learning methods such as decision tree, logistic regression, and neural networks to utilize for fraud detection. So moving to the next slide. So literature survey. So we have data cleaning and processing. This is a more one of the data set to be cleaned and pre-processed to the to enhance data and quality. Then we have future selection. So we have like we can just go with domain knowledge and exploratory data analysis to do the future selection and model selection. The selectary approaches models based on the selected features. So for example, if we want the particular feature, then we can select the particular model. So that is the model selection. So model training and evaluation is nothing but like training the selected models for processing the data and by selecting a suitable algorithm. So model optimization is the model. It is the model performance is not set. If the model performance is not satisfactory, then that can be optimized and tuned hyper parameters and select different features. So model deployments, once the optimization and validation is done, then it can be deployed into the production servers. That is more about the literacy. Then moving to the steps. So we have data extraction. So the data will be extracted and so the once data extraction is done, then it will go to the future selection where it will just select the model, the some kind of models and kind of things, and we'll go. Then it will just analyze and it will just check the missing value. If missing value is there, then it will just do the treatment. Then it moves to the outliner treatment. So the outliner treatment refers to the process of the identifying and handling the outliners in the dataset. The outliners are data points that significantly deviate from the rest of the data in sample or population. They can occur due to the errors in the data collection, measurement, inaccuracies, or rare events. Outlier can have a substantial impact on the statistical analysis and potentially skewing results and affecting the validity of conclusions. Then we have uh, univariate analysis. It is a like statistical technique used to analyze the described data involving only one variable. It is the simple form of the data analysis and focuses on the understanding the distributions and central tendency, depression, and other characteristics of the single variable in the isolation. So univariate analysis is particularly useful for gaining insights into the individual attributes of the datasets before moving on more complex analysis that involve the complex variables. Then model building is like uh, model building is like the once it's everything is done, then model build steps will happen, and finally we'll just go for report making. So moving to the data structure, this is the data structure we can just utilize. So it's like predict or given details of the customer, age, like age, gender, and zip code, merchant. So category wise. So some we just give some whether the fraud will it will happen or not. So the whole purpose of the model is just to explain very simple terms, like we just building the different machine learning models like random forest example to predict the given details of the person, that person will go for banking fraud or not. And we receive this much accuracy using those models. So moving to the next slide, we have hypothesis. So hypothesis, some of the anti-fraud learning that help the financial organization so better and prevent the elimination of fraud by using XGBoost, Kin, and Random Forest. So the XGBoost and Kin and Random Forest are just some of the anti-fraud machine learning tools that can help the financial organization better to detect and prevent the elimination of fraud. Then moving to the next slide. So EDA. So EDA is nothing but exploratory data analysis. We used to analyze the data kind of points and so dependent variable frauds are like we just need to predict the particular customer having this detail will do for banking fraud or not. That is, we can predict like out of 100 people, say for example, there is a possibility of 1% of fraud. So this can be identified. This can be done using undersampling and oversampling approaches. So next graph is like the sector-wise fraud. So next, moving to the next line. So model approaching, it's like we have some steps for model building. So first we just load the dataset into Python. So then it will pre-process the data by handling missing values, scaling and normalizing the data and removing the outliers. The next step is like split the pre-processed data into training and testing sets. So next, like evaluate the performance each classifier on the test data using metrics and such as accuracy, precision, recall, F1 score, AG, ROC. So compared to the performance of each classifier, select one which best gives best performance. So further optimize the selected classifier by turning its hyperparameters using the methods such as grid search or random search. Train the optimized classifier on the entire dataset, then save the model for later use. That is all about model building. So moving to the next line. So we are just using two models here, just to see which model is best suited for this. So one is like random forest classifier is an assemble learning technique that uses the series of decision trees to make final prediction. The other one is XGBoost. It's an example of gradient boosting method which merges several relatively weak models into one robust one. To determine whether given transaction was fraudulent, both models were trained on the dataset. The optimal number of the trees, maximum depth of each tree of the random forest classifier, and hyperparameters like learning rate, maximum depth for each tree. The total number of trees of the XBoost were determined by optimizing the models with a grid search. So moving to the next slide. So these are all the results of both EXG and random forest. So you can see like the random forest make multiple decision trees. They have come up with values, so which gives the prediction. So there is determine the accuracy prediction or not. So the other graph is ROC or receiver operating characteristic. It is a graphical representation and evolution of metric commonly used in the binary classification tags to assess the performance of the classifier. So the next one is the result of XFG. So XC booster. So this is the result of XC booster. So and moving to the next slide. So the results of this both we have taken. So it is represented as confusion matrix. So the positive, true positive, false negative, and true negative. With high true positive rates or low positive, so the negative rates, the results show all models work quite well, but the similar results were seen using the random forest classifier, which yields for like 171,433 true positives and 4,800 erroneous positives. It had false positive rate of 0.6%, meaning that properly recognized 0.3 of fraud cases. With true positive of 99%, 99.7% and false positive 0.3% respectively, the XGBoost model achieved the best results. The model properly detected 99.8 of the non-fraud cases with only 310 erroneous negatives. So in conclusion, so we compared both as I shown in the results and I explained over the graphs. So in conclusion, we have both models are good. They have given good performance. So when we observed that XGBoost was the best accurate in predicting both fraudulent and non-fraudulent transactions measured by the true positive and true negative rates. Overall, the results XGBoost model were encouraging, suggesting the financial institution may utilize to the data set and prevent the credit card fraud. As a result, fraudsters constantly adopting new methods to stay under the radar. The model would need to be continuously updated and enhanced. So these are some references I used in this report. And thank you so much for everyone for this opportunity. Thank you.